Everything is not perfect, right? So if everything is not perfect, we don't get theoretical yields. We get actual yields, okay? When we get back from break and we have the opportunity to do the labs that I have picked out for this chapter, you're going to do the stoichiometry on paper. That is assuming everything comes out, perfect at 100%. That is going to be your theoretical yield because it's done on paper. That's the maximum amount of a product that can be produced from a given amount of reactants. Why did we learn how to do limiting calculations in the first part of this section? That's the amount that we're given. It limits what we can make. If it is limiting the amount of product that can be made, do you feel like that is a maximum amount produced? It's the most that you're going to get. Because once that limiting reactant is gone, what happens in your reaction? Stops. There is no more reaction. So the limiting amount always gives us the theoretical yield, what we're making. But now let's just pretend we've done that calculation on paper. We see and we estimate what that yield is going to be. Then we go back in the back and we do the lab.
And we get the actual yield.
Why are we getting actual?
Because not everything's perfect.
Not everything is perfect. This is the measured amount that you obtain. I always tell you to think about when you do these, you're going to get an amount that you can actually hold in your hand and actually go over to the balance and weigh it. That's why we call it actual yield. Okay? Is there a difference between the two?
Yes.
Yeah. Theoretical, perfect world setting. Actual, real world setting. All right? And do you want to know how you can tell how good you are?
Yep.
Compare the two.
Oh, if it's close.
If it's close, you're going to get close to 100% yield.
If you have Danny in your
But if you have Danny in your group, yeah, lowers it just a little, right? So let's go through this process and talk about what it's called to compare those two. They are percent yield. And anytime, when we've talked about this before, anytime that you have a percent in the definition, it's a ratio that you multiply by what number? 100. Our grades that we get in classes are percents, right? We take the ratio of points earned by points possible. That's a division, which is a ratio. We multiply by 100. We did percent composition earlier this year. Percent of one element in the compound divided by the entire compound, and then we multiplied by 100. So here, for percent yield, when we look at this equation here, this one right here, let's talk about like what are you given and what do you have to do these calculations. Well, I'm saying, do you feel like, because you've got 2 of these problems tomorrow, are you going to have enough time to do 2 labs?
No.
Mm-mm. So probably this one has to be given in the question, don't you figure?
Oh, yeah.
Since you can't do the labs tomorrow to do these calculations, that one must be given. So that would leave me the thought of this one down here is probably what you are calculating, wouldn't you think? Now, the calculations that we do are not new. They're the exact same calculations we did in section 2 that all of you did well on the quiz. Only thing you got mixed up was your ratios. But you knew how to do the T-charts, right? The only thing y'all got mixed up yesterday when we talked about the quiz was like putting, like you didn't know where to put the coefficient numbers, and then some of you didn't even know you were supposed to balance them. That's stuff we can fix. Okay, don't worry about that stuff. That's second nature. You knew how to put your T-charts together. That's the process. Okay, so you're in good shape. Don't feel like you're completely lost and out to sea. because we can get you back to where that you need to be. All right? So in the process, this is the only thing new today. Okay? Let's look at a sample problem and really pick out what we're doing here. We're not going to work this first one. We're only going to talk about it. As kids that are going to go into some sort of secondary education, you've got to realize that there are some things when you go into those next classes, those next level classes, you got to do a little bit on your own. And so what I have learned by talking with some of y'all, you do not pay attention to these problems that are already worked out for you. Do you know why they're working them out for you?
So you have an example.
So you have an example. They show you how to do it. Not only do they just slap numbers down there like I would do if I was talking to you about it, but they go through here and they are literally writing everything out. And I know that there's words on there and everybody hates to read, but if you'll follow those examples, it leads you to where you need to be. Okay, so that's what we're doing with these. So let's look at the way the question is worded, because there's going to be something given that I have to use, correct? So I need to read it, to interpret it, to see which one of those numbers are what I'm using as my actual yield. So, one industrial method of preparing chlorobenzene is to react benzene with chlorine as represented by the following equation. When 36.8 grams of benzene react with excess chlorine, the actual yield of chlorobenzene is 38.8 grams. What's the percent yield? So we got a couple different numbers there, right? Do we have a chemical reaction written for us already?
Yes.
Is it balanced?
I gotta check.
Yeah, we always have to look. So if I'm looking, you can just do a simple spot check. You've got 6 chlorines on the reactant side, or I'm sorry, 6 carbons here, 6 carbons on the product side. You've got 6 hydrogens, 5 there, plus 1 on the other side makes 6 on the product side. Right? Last one is chlorine. You got 2 on the reactant side and 1 there, and 1 more makes 2 on the product side. Are we balanced? We are. What ratios do you have going all the way across? 1 to 1. All the way across. But when I look at these things, remember how I suggested to pick out what your known is and your unknown?
Yes.
Go ahead and do that, because we're not doing anything different than we did in section 2. Okay? So if it were me and I'm looking at this, I've got when 36.8 grams of benzene react. So that's a given. 36.8 grams. With excess chlorine. What do we know excess chlorine means?
Leftover.
Yeah, you got extra. You got some left over. So do I care about chlorine? No. I don't have to worry about it. So isn't that in code telling me that that benzene is my limiting one? If it says that you have excess chlorine gas, don't worry about it. Okay? So then it says the actual yield of chlorobenzene is 38.8 grams. Well, so if I have an actual yield, don't I need to calculate the theoretical of the same compound? Agreed? So I'm writing on here that this is my unknown, and I want to calculate it in grams because the other one is in grams. What if your actual yield had been in moles? Calculate the other one in moles. Just make them match. Okay? How do we feel right now before we look at how to calculate? Yes or no?
Yes.
Yeah? Yeah? Yes? Shane?
Wait. So, if you still use the excess chlorine like in the problem?
Nope. It's extra. We're only isolating the benzene and the chlorobenzene.
So you only use those two?
Yep. Okay? So let's look at how that they're suggesting us looking at these things. That right there that says analyze, that's what we just did in that problem. We picked out our mass of benzene, our mass of chlorine was excess, actual yield, and we figured out we're looking for the percent yield. So then we go through and they're actually, your plan of action is that T-chart system that we've talked about. Just doesn't have the numbers in it, right? So as I go through there, just kind of think about how that those T-charts are set up. It also talks about not only is this equation here the one that's going to be giving us an answer, we've ultimately got to use that percent yield as well. Yes? So let's look at how that they put the numbers together. So if we start right here with my limited amount, limited benzene, I've got it in grams, but I can't go from benzene to the unknown unless I have moles, correct?
Mole brew.
Just like in section 2. You got to go to moles. So if I have grams, they're using that molar mass fraction. Agreed? After the molar mass fraction, if I have moles of benzene, that's my mole bridge going from one compound to the other. That's good for me because I'm canceling the reactant and I'm going to what? The product. Then we're using the mass of chlorobenzene for another molar mass calculation, right? All of those things allow us to cancel our units as we go across till we figure out that the answer is 53 grams of chlorobenzene. How do we know that that's our theoretical yield?
Because you're not doing a lab.
I'm not doing a lab for it. Okay, that's a good point. Am I doing the stoichiometric calculation for it? Yes. So if I'm doing that calculation, that is my 100% yield that I would get as a perfect, setting. So then, here's the only new part, because we've done this in section 2, right? Everybody felt good about section 2. Now, here's the only new part. Actual yield that was given, theoretical yield that we just calculated. We're going to divide those two numbers, multiply by 100, and then what do we get? 73%. Now, that is telling me that when they did this lab, they had about 30% error. Okay? They could have gotten more, right? Maybe if they needed to go back through and try it again, they would refine their purpose just a little. All right, let's do one on our own. All right, here's good study habits. When I'm going through this, you're not just writing down what I write down. You're thinking about what we're writing down and why. Okay? So it says menthol can be produced through the reaction of CO and H2 in the presence of catalyst. Gives you your equation. Is it balanced?
No.
Yes. Okay? If I'm looking and I count the carbons, they are hydrogens. I got 4 of them. I got 4 on the product side, 1 oxygen on both sides. Everything's good. Now it says, if 75 grams of CO react, what's that mean? Okay, go through, and if it were me, I'm writing down that I have CO on the reactant side, right? And it's saying I'll start with 75 grams. To react to produce 68.4 grams of CH3OH. Let's see. Different color because that is a different quantity. So it's telling you if they did this lab, that's what you would get. What do we know that number is? If we did the lab and that's what they got, thank you. That's your actual yield. Okay? What's the percent of that yield? Now, if after you write these numbers out, does it kind of point you where you're going? That's why I've always done these this way. It's not because that's the end-all be-all way. That's just the Marlin method of putting it to where that it isolates those things for me. When I write it this way, I'm reading just from the question, and that tells me I'm going from the CO over to the other one, right? You don't even have to know the names of them. So theoretically, how would I figure out if I start with 75 grams, how much of the other one would I make? Probably going to have to do my T-charts, aren't I? So let's do that. Let's start with 75 grams of CO. Can I use grams of CO? What do I have to do with it? Turn to moles. So I've got grams of CO that will go on the bottom, moles of CO that will go on top. Do we agree? 16 plus 12 is 28, right? So quick math, 28 grams of CO and 1 mole. How did I do what?
Molar mass strain.
Yes. Okay, so why did I do that fraction? Because it canceled out CO. Then, am I to where I need to be, or do I need to do another T-chart? Another T-chart. Which T am I going to make this time? Mole to mole. So, mole of what goes on the bottom? CO, because I want to cancel it out, right? What goes on top? Mole of CH3OH. Right? The grams per mole fraction we got from the periodic table. Where do we get numbers for your mole to mole?
The balance.
So I'll look up here. I've got a 1 in front of the CO and a 1 in front of the CH3OH. So, 1 and 1. What did that allow me to do? Yep, cancels out mole of CO. I was given grams as my actual yield, correct? So I want to go to grams of my other one. So mole of CH3OH, grams of CH3OH. I'm going to do this one quickly for you again since we're on a short day.
32.
What is it?
32.04.
So 32.04 over what number?
1.
1. Notice the only time I ever used the coefficients was when it was moles to moles, right? That last fraction allowed us to do what? Canceled everything except for grams of your unknown. Clay, did you get the answer to this one yet? Okay. 85.83 grams. Okay. Yeah, I got it too. Well, using those numbers we have, assuming that the masses are all correct. All right, so what is that 85.83? What's it called? Theoretical yield, because we are using the ratios not of what we have in our hands in front of our face. We're using the ratios of a balanced equation. Yes? So now how am I supposed to calculate the actual yield, or I'm sorry, the percent yield?
You gotta put actual yield.
Remember, it is actual yield over theoretical yield times 100. Plug her in. Actual was 68.4. This one is 85.82 times 100. 80%? That's a good lab. They only had 20% error. That's good. So what's the only thing new is figuring out what? The percent. In my opinion, only my opinion, this is easier than the limiting. Do you know why? Because it tells you what the limiting is, right? Now, what would be the difference if we had one where I had to find the limiting? You just do your stoichiometry to moles, right? Go do your stoichiometry to moles of whatever. In this case, they wanted us to go to that CH3OH, right? Do your limiting of both reactants to that one unknown. And then when you figure out which one is limiting, do your molar mass calculation and you've got your theoretical yield. You don't have to do 15 T-charts. Do you see what I'm saying? Do both of your stoichiometric calculations separately to your unknown. Whichever one makes the smallest amount of that unknown is your limiting, right?
Yes.
So then, just from there, do your one extra little T with molar mass of this. You're essentially going to like fast forward to this one right here. That last T after you find the limiting. You're still going to get this number, right? Then what do? Carry on down here to the percent yield, okay? But on the quiz tomorrow, what if they only give you one limiting reactant? You do it just like we did here, right? They're telling you what's limiting. They're telling you what's excess, so you just start from there. Okay? All right, you look over this problem and you think about whatever possible question that you have while I pass out that study guide.
I got a question.
Okay.
Will the actual yield always be the product, like it produces?
Always, yes,
Okay.
that's a good point. An actual yield will always be a product because they're wanting to know how much you produce. Okay? Think about that arrow. What do we call the arrow? The yield sign. So it's an actual yield, which means that is the product side. Okay? Clay?
So this stuff is gonna be combined with like number 25 and 26.
I mean, I'd have to look back. It could, but there's on. I mean, you're still listen. Don't think about that that limiting reactant stuff. Don't think about that being hard. You're just doing what you did in section 2 that you're comfortable with. But instead of doing it once, you're doing it twice. Okay? Go back to what is the easiest part for you. Because I promise you, it is not different than section 2. It's really, really not. You're just doing it twice. That's the only difference. I think that y'all have these preconceived notions that it's just so hard that you can't do it, so therefore you just can't do it.
Bingo.
Okay? Don't mentally psych yourself out because it's really not very hard. You can do it. You've had a great teacher.
Yeah, Miss Gilbert was good.
She really was. Okay?